So today I'm going to teach you how to classify elements based on their electron configuration. So elements can be sorted into different groups based on their configurations. So we can either categorize them as a noble gas, a representative element, a transition metal, or an inner transition metal. So let's first look at the noble gases, which of course are in group 18. So they were previously called inert gases because they rarely take part in reactions. They're very stable, which means they don't react. They have an electron configuration that has the outer S and P sublevels completely filled. So for example, we have helium 1s2. It only has one sublevel, the 1s, and it can fit 2, and it has 2. It's filled. Here's neon 1s2, 2s2, 2p6. The outer S, the outer second principal energy level, the 2, has an S and a P sublevels that are completely filled. The S can hold 2, and it has 2. The P can hold 6, and it has 6. Here's argon, the third principal energy level. The 3S and the 3P, again, are completely filled. There are the filled outer shells. So if you see an electron configuration without a name, and you see the S and the P is completely filled, you know it's a noble gas. Next, let's look at the representative elements, groups 1, 2, and 13 through 17. So they display a wide range of properties, which is why they are a good representation of all the elements on the table. They have metals, they have metalloids, they have nonmetals. That's why they're called representative elements. The configuration of them is that their outer S and P electrons are not filled. They're filling, but not filled. They're not completely filled up with electrons yet. So next we have the transition metals. Transition metals are the elements in what used to be called, or sometimes called, the B columns of the periodic table. We will call them groups 3 through 12. The outer S sublevel is filled, and we are now filling the D sublevel. So if you see an electron configuration with electrons in any D sublevel, you know it's a transition metal. They're called transition metals because they're a transition between the metal area on the periodic table and the non-metal area. So here's an example. If you have this 3D1, as long as you see a D, a filled S and any electrons in the D sublevels, you know it's a transition metal. Next, we have the inner transition metals. There's these two rows in the bottom of the table here. So their outer S sublevel is filled, and they are now filling the F sublevel. So if you see an F with electrons in it, you know it's a inner transition metal. In reality, you'll probably never be asked these because the full configuration would be really long. You could write it shorthand like I have here. This would be rare on a Regents exam. So let me show you an easier way to classify elements based on electron configurations. So suppose you were given just the electron configuration like this here, and I asked you to classify it. Now you have a 25% chance, and I just told you, based on these configurations, how to know which one it is, but there's actually an easier way. You can just count the electrons and locate the element on the periodic table. So this configuration here has a total of 16 electrons. There's only one element in the normal non-ion state that has 16 electrons. Remember, the atomic number also equals the number of protons, but it also equals the number of electrons. So sulfur here has 16 electrons. So sulfur is considered a representative element. So you should be able to classify elements based on their spdf configurations. The noble gases have filled S and P orbitals. Representative elements do not. Transition metals are filling the D sublevels, and the inner transition metals are filling the F sublevels. Now you can learn this and practice this and study it, but when in doubt, just count electrons and find out which element it is on the periodic table. Remember, the number of electrons also equals the number of protons, which is the atomic number, which will allow you to locate it on the table, and based on its position, you should be able to classify it.